Okay, here's the video for examples to do with your homework. So I'm going to try to do this relatively quickly since the notes video is kind of long. That way it doesn't take very long to go through this. Just some more examples if you want to look at more examples for your homework. So you want to draw a sketch and shade the region, and then you can pick one. You don't have to do them all. Chart, the normal CDF. I guess I should write Desmos. Desmos, that's implied when you do normal CDF because that's the calculator. Desmos or the calculator. Or the inverse norm to find the given values. So we want the probability that z is less than 2.06. So I want to draw this. I should just let Desmos draw it for me. 2.06 because it looks much nicer. So on the calculator, I would do normal second bars, normal CDF, negative 1,000, 2.06. On the chart, I would go to 2.06 and write down the value. On Desmos, it gives me 0.9803. They should all give you 0.9803, regardless of which way you do it. And like I said, it gives me a nice little picture here. Okay, and I'm not going to do it all the ways, just for the sake of time. So if you need to see another option, like the chart, if it gives you a different answer and you have a question about it, just send me a message, please. So the probability that z is less than negative 1.47, here that is, because remember all these, your z's, your mean is 0. So again, on the calculator, I would do negative 1,000 as my min. I really like how Desmos does it though. It just says min and max and there's no confusion. So that one is 0.0708. 0708, and there's my picture. If I want it to be greater than, z is greater than 1.03. Get worse and worse on drawing these as I keep doing videos. So then on the calculator, I would do normal CDF and do 1.03 out to like negative 1,000. Desmos automatically does the infinity for us, so I'm going to change my min to 1.03. And I get 0.1515. And if you use the chart, remember for greater than, the chart only tells you to the left, so you'd need to subtract whatever 1.03 is, subtract it from 1 if you want to use the chart. Most people don't choose to use the chart. If I want greater than, negative 3.06. So way down here is negative 3.06, and I want greater than it. Well, that should be almost 1 because that's almost all of the data. So negative 3.06, which it is. So we've been rounding to 4. So if you round and get 1, you don't want to write 1. You want to put 0.99889 is fine. It's just really, really close to 1. So you can write it out to 5 decimals if you need to. To do between two numbers, if you use the chart, you got to take the bigger one minus the smaller one. If you do the calculator, you go to second vars, normal CDF, and then do your min, comma, your max. Same way with Desmos, you change your min and your max. Negative 1.65, I forgot to draw it to 2.31. So negative 1.65 to 2.31. Let me draw it real quick here. So I've got here's negative 1.65 and here's 2.31. Like I said, when you all sketch these, they don't have to be super perfect. 0.9401. And then the last one here, 0.52 to 3.24. So let me draw that one. So zero's in the middle. So here's 0.52, way up here's 3.24. And so I've got 0.52 and 3.24. So it's 0.3009. Okay. So you want to find the z-score so that 35% of the area lies under the standard normal distribution that's to the left. So we want to find it so that 35% is over here. And so you can use that program on Desmos like I did. For this one, I'd actually rather use the calculator. So it's always nice to have options. So if you prefer one, stick with it. if you're like me, you like different things at different times. So inverse norm of 0.35, my z is negative 0.39. The next one is find the z-score so that the area to the right is 28%. So over here's 28%. So again, if the inverse norm or that program on Desmos, either one, only does the area to the left. So if I do 1 minus 0.28, that gives me, I guess I could have done that in my head, but that gives me the area to the left here. So this is 72%. So I'm going to do inverse norm. Second bar is inverse norm of 0.72, and I get 0.58. So z is 0.58. And find the z-score so that 60% lies between two z-scores. So again, here's 60%. So if I know that there's 60% between them, then that leaves me 40% for the two tails, which means 20% has to be here and 20% has to be here, because it has to all be symmetrical. Mine doesn't look symmetrical, but it's supposed to be. So if I do second bars and inverse norm, I get of 0.2, I get negative. So 1z is negative 0.84, which means the other z has to be positive 0.84. So you could write z as plus or minus 0.84 is fine. Okay, for the last page, so that was just using z's. So now we're going to add in the x's. So assume that the mean is 27, standard deviation is 6, and it tells you that there are multi-step problems. So we want the probability that x is less than 25. Well, so how do we find z? We find z by taking x, 25, minus my mean is 27, divided by, so there's mu, and here's sigma, divided by my standard deviation of 6. So if I do 25 minus 27, I get negative 2, divided by 6 is negative 0.33. So this is the probability that z is less than negative 0.33, which on a graph looks like this, because here's 0, so negative 0.33 is here, right there's 0. And then I can go back and I can do normal CDF and do negative 1,000 comma negative 0.33, or I can let it do infinity and do this, or I can look at my chart and just look at negative 0.33. Anyways, no matter what I do, I should get 0.3707. Okay, the probability that x is greater than 31. So again, I'm going to find z by using the formula 31 minus 27 divided by 6. And that should give me 0.67. Remember, z round to 2 decimals, probability round to 4 decimals. Could put equals here. So this is the same as z being greater than 0.67. So again, here's my graph. Up here's 0.67, because there's 0. I want greater than. So on the calculator, I'll do normal CDF 0.67 comma 1,000. On the Desmos, I'm going to do 0.67 and then let it do infinity. On the chart, if I look at the chart, I'm going to take 1 minus whatever the value is at 0.67. So this is 0.2514. Okay. For the last one, greater than 44, again, 44 minus 27 divided by 6, z is 2.83. And so my probability that z is greater than 2.83. So again, that's the area to the right. So on the chart, I'll need to do 1 minus. So I got way up here is 2.83. On the calculator, I'll do normal CDF 2.83 comma infinity. On Desmos, I do 2.83 and I get 0.0023. Okay, so there's those. So like I said, I'm doing this kind of quickly because I went slower in the notes, and this is, just extra examples to help you on homework. And if you have any questions at all, please let me know. You can, and if you search normal distributions, you can find all kinds, like the Super Bowl points happens to be normal, which I think is pretty cool. But anyways, find the raw score such that 15% of the area is lies to the right of that value. So we want to know what is the raw score so that 15% is to the right. So we want to know what's Z and then what's X. So to get Z first, you can run that program again, or you can do inverse norm on the calculator if we have 15% to the right, then that means we have 0.85 to the left, or like I said, you can do 1 minus 0.15. You need the area to the left, so however you want to do it. So Z is 1.04. So 0.15, that means this down here is 0.85, or 1 minus 0.15. So if I know Z is 1.04, my X is Z times sigma, so 1.04 times my sigma, still the same thing, 6 plus mean is 27. I forgot to write that down, so 1.04 times 6 plus mean of 27, I get 33.24 minutes in this case. And then for our very last one, want to find the raw score such that 13% lies to the left. So way down here is 13%. So I'm going to get Z and then I have to find X. So 13%, I'm going to do inverse norm of 0.13. And I get negative 0.13. So Z is negative 1.13. So X is negative 1.13 times 6, which is my standard deviation, plus my mean. So I'm going to do negative 1.13 times 6, my standard deviation, plus my mean, 27, and I get 20.22 minutes. Okay, so that's, like I said, extra examples so that you can, if you need extra examples, and if you have any questions at all about normal distributions, a lot of things are normally distributed, and so it's good to find probabilities or go back and forth between your Z-scores and your X's and so forth. You've probably talked about them with like testing when you're teaching and all that. So if you have any questions at all about any of this or about your homework, please send me a message.